Hey everybody, review video for chapter 6a, days 1 through 5. So the first one says, state whether the graph is decay or growth, state the translation, horizontal asymptote, domain or range. So growth or decay, we look at our base is 6. That means that's bigger than 1, so that means growth. State the translation. When we look at our translation, this tells us left or right. It's the opposite. So this is going to go left 1. When we do the up or down, that's that part right there. So this is going to go up 1. That up 1 also tells us what our horizontal asymptote is going to be. We take that and then we just go y is equal to that. So y is equal to 1. So I'm just going to go ahead and on my graph, put my horizontal asymptote line. What else do we have to do? State the domain and the range. Do the y-intercept, I guess. We just want to do this, not too bad. If we want to do the y-intercept, just kind of sketch the graph. That means my x value is going to be 0. If I put 0 in there, I have 1/2 times 6 to the 0 plus 1 is 1 plus 1. So that's 1/2 of 6, which is 3, so that's 4. So my y-intercept is 0, 4, so my y-intercept is right there. If I wanted to find another one, I could certainly find another one. I could put in -2, or I could put in 2, those things into my original equation just to kind of give myself another one. If we did that, what we're going to find out is the graph of this thing is going to probably not curve like zoomy like mine did, but that's what it's going to look like. The domain goes from -infinity to infinity. The range goes from our asymptote line from y equals 1 to infinity. That's the first one. Number 2, growth or decay. We look at our b value, it's decay. It's less than 1, greater than 0, so it's decay. If we look at that, opposite of that, telling us left or right, so this is going left 1. That tells us up or down, so it's going to go up 2, which then tells us our horizontal asymptote. Horizontal asymptote is y is equal to 2. I'm going to go ahead and graph that in there right now. That's done. Next thing, just to help myself graph it, I'm going to find the y-intercept. So the x value is 0. The x value is 0. I've got 5 times 1/2 to the first plus 2. It's 4.5. So 4.5 is about right there. We said that this was decay, so it's going to go like this. It's going to come down and come around and approach our asymptote line, but not pass it. Domain, again, it's -infinity to infinity. The range doesn't start till it gets to 2, and then goes to infinity. Ta-da! Again, if you need to make a table out of it, some of your teachers may have said, let's make a table out of this. If your teacher said make a table out of this, then make the table out of it. But you don't have to. Sometimes you can just sketch it. All right. Number 3 says Marcus makes an investment of $10,000, increases by 4.2% each year. Write a function that models the investment. So because this is each year, it's just essentially simple interest. So our formula is going to be y is equal to our principal amount times 1 plus, we can just do the rate. Because it's yearly, our n value is technically 1, so it doesn't do anything good. Make sure you move it 2 spots, so 0.042. To the time, which we don't know, which is x. Probably a more accurate way to write this is 1.042 because it's growing. So there is our formula. And then to calculate the formula, you're going to go with 10,000 after 20 years, 1.042, and then you're just going to make that a 20. And you can put that in your calculator just like you see it. Hit 10,000, hit a parentheses, go 1.42, and then hit the caret in 20. And when you do that, you get $22,000, 769 more dollars, and 55 more cents. So $22,769.55 is your solution for that one. Number 4, you buy a car with initial value of $20,000. The value depreciates, so that means it's going down. Write a function model, so it's going down. So we're going to write the function. It's our principal. Now because it depreciates, it's 1 minus 0.15 to the x, or again more accurately, 0.85 raised to the x power. Again, 2 spots, percent. Now after 8 years, we have to calculate it. So we're going to go 20,000 times 0.85 to the 8th. And when you do that, you get $5,449.81. And there's your solution for question number 4. Question number 5. Find the amount of the account for the given principal, interest rate, time, and compounding period. So we're compounding, so we're going to either use the compounded continuously or compounded annually or one of those. So the first one, principal, so it's compounded continuously. So compounded continuously is the amount is equal to the principal times e to the RT power. So our principal is 1,300, e to our rate, 2 spots, so 0.024 times our time, which is 6 years. So this is what our amount, let's make this an A instead. That's what our amount is going to equal. When you calculate that, I get a calculator out now, like I didn't need it for the last one. 1,300, second E, and then inside parentheses, 0.024 times 6, close the parentheses. I get $1,501.35. There it is. Number 6, compounded annually. So compounded annually just means it's done once a year. Annually means once a year. So we've got to use the amount is equal to our principal times 1 plus our rate divided by n to the nt. But now our n is just 1. So our amount, A, is going to equal our principal, 5,100, times 1 plus our rate, which changed to a percentage, so 0.057. Now it's annually, so technically it's just divided by 1, so it's really not doing anything. And then 1 times our t value is 4. So this is 5,100 times 1.057 raised to the 4th. So 5,100, parentheses 1.057, that raised to the 4th. 6,000, put my answer here, sorry, this is bad. $6,366.05. Annually means once. Number 7, compounded quarterly. Because we're compounding this quarterly, quarterly is 4 times a year, so my end value is going to be 4, so we're going to use this one again. So my amount at the end is going to be my principal, 1,400, times 1 plus my rate, 0.037, divided by 4, because it's quarterly, times n to the t, so 4 times 10. So calculator. How I'm doing this on my calculator is I'm going 0.037. I'm dividing that by 4 and hitting equals. And then I'm going to add 1 to that. So I'm not going to clear the calculator. I'm just going to hit plus 1. So now I've got 1.00925. I need to take that to the 40th power. So I'm going to take that, I'm going to hit the caret button right there, and I'm going to go type in 40 and hit enter. And now I get 1.445274444. Try that on your calculator, make sure you get that. Now, I need to take that times my initial amount, which was 14,000. Oh, I forgot to put a 0. Sorry, that should be 14,000 now that I look at the problem. That should be 14,000. So I'm going to take that times 14,000. And when I do that, I get $20,233.84, rounding to the nearest cent, okay? Make sure you try this a couple times on your calculators to make sure you can get that using your calculators. There are other ways to do it on the calculator. You could probably just type it in, 1400, put a parentheses, 1 plus 0.037 divided by 4, close parentheses, caret 40, and you probably get the same answer. Nope, you don't. Well, yeah, you do. You get the same answer. I just put 1400 instead of 14,000 again. So you get the same answer if you just kind of string it out, but be careful with those, okay? Number 8, compounded daily. Daily is 365. Yes, I have the answers over there. That's what I keep turning on. My computer keeps dying over here. They're over there. I'm just making sure I'm right. So my amount is equal to my principal, 500, try to put the right number this time, times 1 plus my rate, 0.062, compounded daily is 365, times NT, so 365 times 5. So the first thing I'm going to do is go 365 times 5, and I'm just going to kind of doodle that number over here. That's 1825. So I'm going to go ahead and go, like I like to do it, 0.062 divided by 365 plus 1. Now I've got to take that to the 1825 power. I get 1.363398, blah, 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 blah. Take that times 500, and I get $681.69, which is the same thing as Ryan got when Ryan got the answer key. Ryan made up the answer key. So we're all good to go through there. Question number 9 asks us to rewrite in logarithmic form. This is where things should pick up a little bit. So exponential form, okay? Exponential form is anything you have to a power. So since e, that number, is risen to a power, it's equal to something that's equal to exponential form. So put it in logarithmic form. Identify your base. That's your base. So our base is going to be log base e. Our of is going to be this, 0.135. That's going to equal our exponent. But remember, we don't write things at log base e. Log base e is equivalent to ln. So it's equivalent to ln of 0.135 is equal to -2. And that's your solution. And you're done. Number 10, again, it's an exponential form because we've got a base to an exponent. So when we have a base to an exponent, this becomes log of our base, which was 3, 243 equals 5. Done. Move on. Number 11 is log base 10. So this is log base 10 of 1,000 equals 3, which technically is right. But remember, log base 10 is the same thing as log. So you could do log of 1,000 is equal to 3. And you're done. And the last one, our base is 2. So log base 2 of a equals -1. And because that's all you're asked to do, you're done. You don't have to go any further. Number 13. Ooh. Number 13. Now we have to write it in exponential form. It's in logarithmic form. So we identify our base. What was our base in our log is also the base of our exponent. So the base of our exponent is going to be 12 to the second power equals 144. And the nice thing about writing these in either really directions, you can check your answer. You can hit 12 to the second. hit 12 to the second on your calculator, it should say 144. 14, our base is 7. Oops. So we're going to write it in exponential form. So 7 to the x is equal to y. That's your solution. ln. ln, remember ln is log base e. So it's still written as a log. So it's e to the 4th is equal to 54.5982. I think if you look at the answer key on this is wrong. We probably had to go in and change the question because there probably wasn't an ln one in there, and we went in there and changed it and didn't change the answer. That's why the answer is wrong on the answer key. And this one, remember, if there's nothing there, there's understood to be a 10 there. So it's 10 to the second equals 100. You're done. I'm going to sneeze. Sorry. Number 17. Now we're asked to evaluate using mental math. Oh no, I have to use my brain. So the first thing I like to do is I like to put an x here. It's in logarithmic form. So I log base 2 of 8, I have no idea, but I know what it means. It means 2 to the x power has to equal 8. Now you're supposed to use mental math. So, I mean, could you change it so your bases are the same? So we had the thing where we had a base to a power is equal to the same base to power. Those two are equal. Could you do that? Sure, you could. I mean, my base is going to be 2. That's 2 to the x. 8 is the same thing with a base of 2 as 2 to the 3rd. So now these bases are the same. So x has to equal 3. Could you do it that way? Certainly, 100% could do it that way. So you could also use your brain. What power? 2 to the first is 2, 2 to the second is 4, 2 to the third is 8. It's got to be 3. Okay? But either way, a fraction. So again, I'm going to set it equal to x. So I've got 3 to the x is equal to 1 over 27. Getting these bases the same is a little bit more difficult. So I'm going to use kind of the mental piece of this and use some of our past stuff that we've talked about. And we're going from a whole number to a fraction. And we're talking about exponents going from whole numbers to fractions. If I have an exponent that's negative, it means I move it from its numerator to its denominator. So if I can figure out what the exponent would be to make it 27, which would be 3, so 3 to the 3rd is equal to 27. If I make that a negative, remember what we do when we have negatives, we move that to the denominator. So because we move that to the denominator, I'm going to erase this because I don't like how it looks, but we know that 3 to the 3rd is equal to 27. But if I go 3 to the negative 3rd, that's the same as 1 over 3 to the 3rd, which is 1 over 27. So x must equal negative 3. So if you go from a whole number to a fraction, it's just going to be negative exponent. And just think what gets me to 27. Kind of the same way if you go to fraction of whole number. You can use mental math. Easiest questions on the test, evaluate the expression, use your calculator. You literally just hit ln of 5.8, 1.7579. 4 significant digits is probably what you should do. Scientifically, that's what we do. Whatever. Number 20, log of 38. You can use the calculator because the base is 10. So just hit log 38. 1.5798. Again, if the directions tell you where to round it to wherever the directions tell you. Number 21, solve each. Okay, well, if I wrote this as a log, it would be log base 6 of 216 equals negative 3n. You don't know how to do that. Okay, we don't know how to calculate that on our calculator. So this is where we want to have the bases the same. So I've got a 6 here, 6 to the negative 3n. I want to see if I can get 216 to have a base of 6. So 216 squared is 36. 36 times 6 is 216. So those two are equivalent to each other. Okay. 6 to the 3rd is 216. Now they have the same base, So then their exponents have to equal each other. Divide by, you get n is equal to -1. And that's your solution. Number 22, we've got 2 as our base. So we've got to think 16 is 2 to what power? 2 squared is 4, 2 to the third is 8, so fourth. So we've got 2 to the fourth is the same thing as 16. So negative 2p equals 4. So p equals -2. And there you go. Okay. Next one, they were nice to us. Have the same base already. That was nice. So 2b has to be -b minus 3. I'm going to add that to that side, so plus b. So 3b equals -3. B equals -1. That's your solution. And the last one, they're already the same. So -2v minus 3 equals, equals erase, equals 2 minus 2v. So I'm going to add 3, and I'm going to add 2v. So you get 0 equals 5, which is false. So no solution. Nothing will make that work. Number 25, solve each. Now we're only going to be able to solve these if we have base 10 or we have an e as our base. And we have to isolate first. So we got to isolate this. So we got to isolate, I'm tired of red. Let's go to blue. So we have to isolate that first. So we isolate that. I'm going to go ahead and subtract 7 from both sides. So that gives me 10 to the x minus 1 equals 30. Now I've got a base to an exponent equal to something. So we're going to write it as a logarithm. So log of my base, so my log base 10 of 30 equals x minus 1. But again, remember, this is just log of 30 equals x minus 1. Log of 30 I can find on my calculator. I just hit log of 30. I hit that, I get 1.47712. I'm not going to clear that. I'm going to leave it as it is. Now mathematically, I'm just going to think about what I have to do to solve this for x. So I have to add 1. So I'm just going to take my calculator, I'm going to add 1. And I get 2.4 round to the nearest 10,000th. So tens, hundred, thousands, 10,000s. There's my x value. Let me check Ryan's key. That's what Ryan has. Here you go. Trust Ryan. This one, I think that's a time sign. So I'm going to go with that being a time sign. I'm not 100% sure if it's a time sign or not, but I'm going to call it a time sign. So I'm going to go ahead and divide this by 8. I'm going to find out when I look at the answers or not. So those cancel. I'm just going to, so I've got 10 to the 4x. 56 divided by 8 is 7. So that's 7. So I got log base 10, so just log of 7 equals 4x. So I'm just going to kind of work out what I'm going to do. I'm going to divide by 4. So I'm going to take the log of 7 divided by 4. I get 0.2113. That's what the answer key says, so evidently that was a time symbol. Where are we at? 24 minutes. Almost done. Oh, I've got an E. That's okay. We like E's. So we got to isolate it. So I'm going to subtract 5. So E to the n minus 4. 26 is 21. So E is the same thing as log base E, which is the same thing as ln. So it's the ln of 21 is equal to n minus 4. So if I take the ln of 21, and then I'm just going to hit equals, and then I've got to add 4 to it to solve for n. I get 7.0445. There's our solution. And the last one, thank goodness. isolate, so we're going to divide by -7. Negative 52 divided by 7, ooh, is an ugly number. So we get e to the x minus 10 is equal to 7.428. I'm not going to erase that number out of my calculator. There's a whole bunch more to it. I'm just going to leave that in my calculator. So it's the ln, because it's e, so that's log base e, so that's ln of 7.42857. That's going to equal x minus 10. Well, I have that number on my calculator, so I can just go ahead and hit ln, and then I can go second, and then hit the negative key down there, and then it'll say ln of ans, close the parentheses there, and now, or hit equals, and then I have to add 10 to that, and I get 12.0053, and there is your solution. That is the review for the chapter 6A test, days 1 through 5. Good luck on the test if you take it, when you take it. If you're just watching this for some random reason because you like to see my face and you like to do math, good luck with whatever you're doing. Hope you understand how to do it. Have a good one.